What does it really mean for an AI to think? Today, we're diving deep into Claude's memory hack changes everything. Claude's memory hack changes everything. Most users treat every AI conversation as a fresh start. They reset context and re-explain preferences each time. This stateless approach forces you to play on hard mode. A hidden productivity gap emerges as a result. The strategic importance is simple to understand. The ability to accumulate context across sessions matters. It turns Claude from a stateless tool into an asset. Compounding intelligence becomes possible. This way, momentum shifts toward those who build persistent memory. But here's where it gets interesting: the stateless bottleneck. Every new conversation discards prior decisions and project history. Reprompting from zero consumes hours weekly and limits complexity. Existing AI interactions are transactional: ask, answer, forget. This bottleneck becomes more expensive as tasks grow in scope. Stateless use is no longer a choice, it is a hidden tax on cognition. So what's the real problem? Let's talk about why stateless fails context windows reset between sessions unless explicitly managed. Next, no native cross-conversation memory limits Claude's ability to recall your coding style. Importantly, meeting notes or strategic preferences require re-uploading history. Thus, users rely on manual copy-paste or external notes to manage information. More specifically, repeated instructions are needed, which are fragile and time-consuming. Notably, the root cause is a design assumption that conversations are independent. That assumption is now considered obsolete in modern use cases. This raises a critical question: the memory breakthrough. The hack is simple but transformative. Treat Claude as a persistent operating system, not as a disposable chat. By feeding back prior session summaries and decision logs into each new context window, you create continuous memory. No new model features are required, only a disciplined workflow for context accumulation. This turns every conversation into an incremental update to a growing knowledge base. Now, let's zoom in on system. Personalized OS Claude becomes the control layer for your work, ingesting your projects and synthesizing your notes, applying your decision frameworks across sessions. The system maintains a live memory store, preloading relevant context before you type architecture, splits into 3 planes: persistent storage, holds your summaries and preferences. Retrieval determines what to load per session. Execution ensures Claude's responses are grounded in history. Stateless tools become stateful intelligence. Here's something most people overlook: core components. 4 components drive the memory hack. First, a memory store holds session summaries and extracted facts. Second, a preference engine captures your coding style and writing voice. Third, a project registry tracks active context blocks for each initiative. Fourth, decision frameworks provide reusable heuristics and checklists. Together, they form a lightweight knowledge graph maintained by humans. No database is required, just disciplined text artifacts. Think about this for a second. The workflow: capture, reflect, apply. Next, capture by prompting Claude to summarize new insights at the end of each session. Importantly, reflect by merging that summary into your master memory file. Thus, update preferences and project status during this step. More specifically, apply by priming Claude with relevant memory chunks before each conversation. Notably, this 3-step loop takes under 2 minutes per session. Memory grows over time as the process compounds across weeks. Repetition vanishes with consistent use of this workflow, and this is where things get complex. The compounding impact: after 10 sessions, Claude knows your architecture preferences and recurring edge cases. Next, after 50 sessions, it drafts entire proposals using your verified decision patterns. Importantly, the gap between stateless users and memory-augmented users widens exponentially. Thus, each group solves problems at different velocities. More specifically, early adopters build a personalized intelligence asset. Notably, this asset appreciates with every interaction. Productivity becomes a function of accumulated context, not raw inference. But here's where it gets interesting. Future. Memory as default. The hack foreshadows a fundamental shift. Every AI system will maintain persistent memory. Future models will embed native recall and summarization. Vector memory stores will become standard practice. Early adopters gain compounding returns quickly. Tooling will eventually catch up to this workflow. The operating system for your mind is not a feature. It is a practice you can start today. Stateless is the past memory, is the interface